Hello, so we're going to look at 2.1, relations and functions. I suspect that at this point, if you're in Math HL, that this would be pretty much just review. So I'm just going to kind of quickly go through it and then look at a couple of examples. So first thing we're going to talk about, the highlighted words, relation and function. A relation is any set of ordered pairs. It doesn't matter. But a function is a special type of relation. So, and it says here a function is a set of ordered pairs in which the two ordered pairs can have the same x value. In other words, the x value has a unique y value. There's different ways to define a function, but one of the ways that I like to talk about it is saying for every input that you put in, every x value you put in, there is only one y value. So if there's two, it's not a function. So, and also you should know what the domain is, and that's the set of x values, or the input is what they refer to it. And the range is the set of y values, or the output. And I have a little function diagram right over here. Here is the domain, and then when you plug in domain, you get the y value, and that's those are the set of the range. Also, because since the y value, the value of the y value depends on the x value, the y value is called the dependent variable, and the x value is the independent variable, right? And also it says here relation is a function of f if f acts on the elements of the domain, x values, and if f is well defined, i.e. the pairs of it pairs each element of the domain with one and only one element of the range in y. It's another way of looking at what a function is. Also, it says in general a y function of x, you can write y is equal to this notation is f of x. I'm sure you've seen that before. And you can also write it by this. This is sometimes we might write a function like that that's a little bit different. Sometimes they do like to use that notation in IB sometimes. It doesn't come up too often, but every once in a while I see it. But just know that that notation is just the same as it's another way of writing it. Where f is a function that maps x into f of x. The independent variable x is called the argument of the function. And also, to really quickly go over, I'm sure you remember, we can test graphically if a function is, if something's a function by the vertical line test, right? Like, I'll just draw a couple of examples. And right, and the vertical line test says if you can draw a vertical line anywhere on the graph and it only crosses once, and then that's a function, right? So there is nowhere that in that graph that crosses twice, so this is a function. And then this guy right here, obviously you could tell that no, not a function. And then the last one, yes, that one always cross one, so this is a function. Because the first and the last, they satisfy the vertical line test, right? But sometimes we can look at problems like example 1, and they might give you a set of ordered pairs or information or an equation, and we might have to look at it. So I'll look at the first one right here. This is the point -1, 1, -2, 4, -3, 9, 1, and 1. Now I notice that every input, they're different numbers. So no matter what, I know that this is going to go only to one value, so this one is a function. So this one is a function, right? And then the next one, it says 4 to -2, 1 to 1, 4 to 2, and 9 to 3. And I noticed that the first and third points, 4 goes to -2, 4 goes to 2. This one's not a function. I know that because for one particular input value, I'm going to get two different output values, and that can't happen. And then I look at y is equal to 2x minus 1, and I know no matter what, every time I put in a different x value, I'm going to get a different y value, right? So I'm always going to get, I'm not a different one, but yeah, I get a different one, but I won't get two values for one no matter what. I can only get one value here, so this one's a function. Right? And the next one, D, well, I know that one squared is 1, but also negative squared is 1, right? So that means when I can have the two values right here, and this one's not a function. Because I know for one value of the input, I'm going to get two values for the output, so not a function. And then the last one here, it says f maps set A to set B, where both A and B are a set of real numbers, and f, this is the function notation, where x maps up into 1 over x minus 1. And this one's not a function because it says A and B, the set of A values to B, right? So this would be the domain and this would be the range. It's the set of real numbers, but there's a real number that doesn't work for this. We can't put in x equals 1, right? So this one's not a function. Now, if I were to restate this and put in there such that, you know, A is not equal to 1, then I can what we call restricting the domain, and then then in fact this would be a function. But the way they have it written right here, I know that this is not a function. Sound good? Now, let's look at example 2. And it says determine with reasons which of these graphs are functions for those that are functions, write the domain and range of the function. So we look at this guy right here. This one here is a function, right? By the vertical line test. And what's the domain? Well, the domain is going to be all real numbers. And the range will be all real as well. And this one here is not a function, right? Because it's not a function because it does not, you know, pass the vertical line test. Good? Now let's look at this one right here. Pull that up there. And we can look at this graph right here, and we can see that this one is a function. Because you can see it doesn't equal at that point. It's kind of a bad graph, but you don't see a solid dot here, so I know, you know, it doesn't exist right there, but it goes right up to that point. And this is what we call the greatest integer function, right? And it passes the vertical line test. And this one, domain, is all real. Right? And the range would be, you could see it's the set of integers. The range is y such that y is in the element of the integers. And that's how I'd write it, right? It's nothing in between. Good. And then the last one here, this one's not a function because we have two solid dots right here. So it does not pass, not a function. Right? If you were to give a better reason for this, you could just say from the graph, you know that f of 1 equals 1, and I should say f of 1 also equals 2. So not a function. That's a good explanation. That can't happen. And there you go.